Hello, Keystone Algebra students. This again is your favorite math teacher of all time, Mr. Miller. In this video, we are going to talk about graphing linear inequalities in two variables. We're going to have both a y and an x in this equation. So we're going to review a little bit, and then we're going to do a few practice problems here. So the first thing we have to do is we have to first find our boundary line, right? So if we have this y is less than or equal to 2x plus 5, that is going to turn into y equals a dog barking in the background. So next we're going to have to decide what type of line that we are going to use. So if we have the less than or equal to or the greater than or equal to, we are going to use a solid line because those points on that line are included in our possible solutions, right? So this is kind of like when we use our closed dot. So a solid line is analysis is the same as doing a closed dot. And then if it's less than or greater than, we are going to use a dashed or a dotted line. And that's the same case when we are going to use an open dot. So now once we kind of draw our boundary line, we have to decide where we shade. So we are going to shade one side of our line. And really, there's a couple different ways to do it. But I mean, cross off the A here, right? We could do a checkpoint, but we don't. That's not really necessary. If it's less than, we are going to shade below. If it's greater than, we are going to shade above our line. Again, the shaded area, the reason we shade is it tells us all of the solutions to this system. Or sorry, not really the system, but solutions to the inequality, not the system. Right? So we have y is less than 2x minus 3. So firstly, we're going to look at, okay, we're going to graph the line 2x minus 3. We are going to use a dashed line because we are having, we don't have the or equal to part. And we're going to end up shading below this line because we have a less than, right? So we know those three things going into it. So when I look at this line, my slope here, or my y-intercept is going to be -3. My slope is going to be 2, right? That's where the m and the b lie. So we're going to go down to 3, 1, 2, the 1, 2, 3, put a dot. My slope is 2, so I count up 2, right 1, up 2, right 1, and I continue that on through the entire graph. And then I am going to connect that with a dashed line, and I am going to shade below. Again, so all of these points here in this shaded area are going to be solutions, and all of these points over here are going to be not a solution. Let's move on to the next example. First, I notice this is not in y equals form. It is in point slope form. So right off the bat, I know that I can use my points here, or I can solve for y. So why don't we we're going to just solve this one for y. So we're going to distribute. So y minus 3 is greater than or equal to -1/2 x plus 1/2. And then we're going to add 3 to both sides. So y is greater than or equal to -1/2 x plus 3.5, or 3.5. So our equation we're going to graph is y equals -1/2 x plus 3.5. We are going to shade, we're going to use a solid line because we have the or equal to part, and we're going to shade above because it's greater than. So I'm going to go up to 3.5, 1, 2, 3, and then halfway in between. And from there, we're going to count up 1, right 2, up 1, right 2, and the same thing going the other way. Boom, solid line, and then I shade above. Again, the shaded part is solutions. The non-shaded part is going to be not solutions. All right, so go ahead and please move on to the next video then to finish up our notes.